Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this film, we are talking about the parametric linear programming focused on systematic change of C sub j. Let's move on. Let's go to the systematic change in the right-hand side parameter, which is bi. In this scenario, the parameter bi is substituted with bi plus alpha I theta, where alpha I represent the fixed data. Consequently, the problem can be expressed as follows. The objective function of this section is determine the optimal solution as a function of theta. Altering the coefficient of the objective function in the prime model is equivalent to change the coefficient of the right-hand side in the dual problem. This is a very important point we use here. To provide the further information, we will work through some example here. Let's apply the parametric linear program and propose to systematically change the value of the bi and determine the optimal solution for following problem. Consider the theta value ranging from 0 to 25. Based on the value of the theta, we obtain the optimal solution for a given model as presented in this table. So you can see that this is the optimal solution, optimal table. For the value of theta between 1 and 0, the last table, this table, would be optimal because the right-hand side would be positive if the theta between 0 and 1. However, for theta greater than 0, the variable x4 exit here. The variable x4 exit and x5 enter the base using the dual simplex method. In the optimal table, the optimality remains intact for theta ranging from 1 to 5. Here. Nevertheless, for theta exceeding 5, if the theta between 1 and 5, this is the optimal solution. If the theta exceeds 5, the variable x2 here leave the base and the variable x3 enter the base. In the next optimal solution table, for the theta greater than 5, the optimal condition and feasibility table will remain unchanged. The corresponding simplex table is provided for theta is greater than 5, condition theta is less than 25, as we discussed in the example. So the results are summarized in the table here. So dependent on the value of the theta between 1 and 0, 1 and 5, and 5 to 25, you can have the optimal solution for decision variable and the objective function. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by form or filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.